I always receive a lot of questions about the Redox homework. I think students primarily understand the concepts and how to use the equations, but we're running into simple problems. The first thing you need to know is that in WebAssign, it is now defaulting so that the description is minimized. If you click the drop-down arrow, you have more information, and there is a link to the proper reduction potentials that WebAssign uses when creating the homework. It is these values that you need to use when finding your standard potentials, not the ones from the textbook and not the ones that I have provided. And the same was true for your thermo homework. There was a link in the top of the assignment in the description to the values you needed to use. So this piece of information should solve a lot of the questions that or problems that you've been having with the homework. Now, the next biggest problem or potential source of frustration has been question 11. In question 11, a lot of students are just using the equations but not getting the right answers. So using the proper table will solve most of that issue, and now I will walk through the rest of that. So here, when you are working this problem, you need to first balance the equation, and I'm not going to go through that here because you can watch another video to learn how to balance equations. But when you go through the steps and you finish balancing, the number of electrons that cancels out is 6. So when you balance the equation, you get 6 electrons that cancel out, and that is your N value. The other important part will be the balanced chemical equation and what are all the coefficients and the H plus, because down here in the problem you're going to have concentrations that you need to use, and you'll need to know all the coefficients from the balanced chemical equation. All right, so now that we have that information, how do we find E cell? Well, on our table, E cell, the potentials for the chromium half reaction are 1.232, and the iodide half reaction 0.535. And based on what is going on, what is gaining and losing electrons, we would find that the chromium half reaction is the cathode and the iodine half reaction is the anode. So for the standard cell potential, I'll put that up here, you're going to have cathode minus anode to the 1.232 minus 0.535, and I trust that you can perform that calculation. Previously, if you use different values, it may have been close enough to give you a correct value for the cell potential, but the slight difference could greatly alter your calculations for the delta G and the equilibrium constant. So determining this value is very important. Now, for delta G, we can use the relationship negative N F E. So now that you have the correct E cell, you should be able to determine a correct delta G value. Just make sure that you don't forget how this negative sign gets worked into the calculation. Now, to find K is where the biggest problem has arisen. Many students correctly remember that delta G is related to the negative RT natural log of K equation that we learned in thermo, and yes, this relationship still applies. However, you may have a rounded delta G value, and that these values are so large and K is so large that any small difference in numbers could greatly throw it off. So this is the redox chapter, so let's not use the thermo relationship. Let's use the redox relationship. So E is equal to RT over NF, natural log of K. And this is the standard cell potential. So we have determined N, and the rest, the R and the F are constants, and the temperature is 298.15. So you just need to correctly solve for the K value using the natural logs and inverse natural logs as we have been doing all semester. Then if you make it that far and you get to part C, the biggest culprit of error is the Q. So the equation is E for non-standard conditions is equal to the standard cell potential minus RT over NF times the natural log of Q. So again, it's just an equation you plug into, and now that you have the correct cell potential and the number of electrons, you should be able to plug into it, but there is an area of trouble here. We have 1, 2, 3, 4 concentrations. So when you go back up to whatever you have correctly balanced, you will need to remember to look at the coefficients for each one of these. Whatever they are, you're going to raise them to the proper coefficients. And remember that it's products over reactants. And just the sheer number or sheer volume of numbers that you are plugging in there makes it easy to make an error in that calculation. For example, if you're trying to plug it all in, where you're multiplying all the reactants on the bottom, raised to their coefficients, remember that you're going to need some parentheses around that to find your Q, and then remember to take the natural log of that number and continue that calculation without any rounding until you get to the final cell potential. So hopefully that will help to clear up some of your confusion or frustration with this assignment. Again, I think just having the correct table of cell potentials will help. I have placed a cross-reference of which videos to use for which questions in your Blackboard folder for the lecture. So please look for that, and good luck with the rest of the assignment.